Hello. Welcome again. Today I will talk with you about how to compare forecasts. To do this, we will discuss the case of 3 of our employees who are candidates for promotion. Please, come with me to the office to show you the details. These are our candidates. Albert, the young man with blue tie. Beatrice, the red-headed girl. And Charles, the young man with a black jacket and red tie. And our colleague Ford Whitman, who will be in charge of assessing them. Ford is explaining that one of their responsibilities will be to make the daily forecasts of some of the products in our catalog. He has told them that this ability will have the biggest weight on their assessment. Ford will give them a time series, so that they can observe the behavior of the data. And based on the forecast we will assign a grade in this area. Their performance will be measured during the next 5 days. I have asked Ford to explain to you how we will compare the performance of these employees. Ford, please proceed.
Hello, welcome. This is the format I have designed to measure the performance of our employees. Every day as they arrive, they will fill these cells. And at the end of the day we will register the actual sales of the day. Let me give you an example. At the beginning of the first day, Albert entered 319 as the forecast. And at the end of the first day, the actual number of units sold was 286. So that we entered that number. At the beginning of the second day, Albert entered 273. And at the end of the day we entered the number 214. And the dynamics was similar for the remaining 3 days. The same thing happened with Beatrice and Charles. And in this way, at the end of the 5 days we had the cards of each of the employees with their forecasts and the actual data. Now, I will show you how to evaluate a forecast. To do this, I will randomly select a card. The first step consists in creating 4 new columns. One column for the error, another for the absolute error, one more for the squared error, and the last one which we will call absolute percentage error. The error is defined as the actual data minus the forecast. In this example, the first computed error is 13, which is obtained by subtracting 286 minus 273. The second error will be minus 34, which is the result of subtracting 214 minus 248. And in this way we continue filling this column. The next column is called absolute error. And it simply is the absolute value of the error. Those will be the results of the second column. The squared error is obtained raising the value of the error to the power of 2. Therefore, the values for the third column will be the following. Finally, the absolute percentage error is computed with the formula 100 times the absolute error, divided by the actual data value. For instance, the first number in this column is obtained multiplying 100 times 13, and dividing the answer by 286, which results in 4.545. I hope you have no difficulty in finding the other values in this column. Once we have filled these columns, we proceed to compute the average of the last 3 columns. The averages of each column are shown in red at the end of the column. Now, let me talk about the main measures of performance in forecasting. As you can guess, to expect that the forecast of an employee or a method will be exactly the same as something that will occur in the future is too optimistic. So, that what we really want is to select the method or the person with the smallest possible average error. A forecast error is defined as the difference between the actual value minus the forecast, and we usually denote the error with the letter E, the actual data value with the letter X, and the forecast with the letter F. Now then, when we wish to compare 2 forecasts we use some measure of the error. There exist 3 error measures which are widely known. MAD, the mean absolute deviation. RMSE, the root mean square error. MAPE, the mean absolute percentage error. We will start with the mean absolute deviation, also known as the mean absolute error. Its formula is as shown here. And for this example, the value is 19.60. The next error measure is the root mean square error. This is the formula we use to compute this error measure. And, as you can assume in this example, it corresponds to the square root of 673.60. It only remains to talk about the mean absolute percentage error. This is its formula. And as you can assume, for this data set, the value of this error measure is 7.56. This summarizes the results obtained by Beatrice. Now I will show you the cards presented by Albert and Charles. I hope you do not have any difficulty finding the following results. It is important to mention that regularly the three error measures are very consistent. That is to say, if you observe the results, you will realize that Beatrice is the one with the smallest error measures, followed by Charles, and Albert last. This means that Beatrice is the most suitable person in this area. I hope you realize that this methodology applies when comparing persons as well as methods. Besides the foregoing error measures, I would like to mention two other topics. One of them is called the bias of a forecast, and the other is the tracking signal. The forecast bias occurs when there are consistent differences between the actual values and the forecasts. That is, the forecasts may have a trend to be too high or too low. One highly desired property is that the forecast has no bias. The tracking signal is a measure of bias. Let me give you an example of how the tracking signal is computed. Imagine a set of data and forecasts, and next to this set, create 4 columns, one for the error, another for the absolute error, another for the mean absolute deviation, and finally, another column for the tracking signal. To compute the error in each row, you only need to subtract the data value minus the forecast. Once you are done with these computations, the column will be as shown in this table. The column of the absolute error consists in getting the absolute value of the error, which is in the previous column. Now we obtain the MAD in each row. Let me explain how to get the MAD column. In period 2, we only have one data point, and the value in this column is just the average of one data value. In the next row, the value of 26 represents the average of the two absolute errors we have until this period. And so on. For instance, in period 6 the value 18.2 can be obtained as the average of the 5 values up to and including period 6. Finally, we will fill the column labeled as tracking signal. This column is the result of the division of the number that appears in the error column, divided by the number that appears in the MAD column. As you can see, obtaining this column is really easy. It is usually desirable that the tracking signal varies within the range -4 to 4. And that at least half of the values are in the range between -1 to 1. Therefore, we can conclude that in this example the tracking signal behaves adequately. Well, for my part that is it for today.
Ford, I wish to thank you for your support in this session. In the next session we will talk with more detail about the error analysis in forecasting. See you soon.